Hello and welcome back, everybody. I am glad to see you this week on a Monday night. I'm seriously debating just changing it to Monday night. It seems like there is a lot of demand for Monday, so it just depends on how it goes. And I would love to hear from you. Comment down below if you're watching it on a replay, or if you are not watching it on a replay and you're watching it live. Just post a message on there and let me know what you think. It's still early on, so I may mention it a couple of times during the show just to kind of give you guys an idea of what's going on. Um, anyway, so this week's live stream is all about the, obviously we're going to do the news as we always do, but then we're going to get into the solar system, the basics of the solar system, about the four basic components, and about the just different elements of the system that you need to know in order for we're going to try to get down this week into the new people to the industry, the people that really want to look at just the basic core DIY solar. What components do you need for operation and for safety? And we'll kind of go through both of them. I'll put it up on the whiteboard, I'll draw it out, and then we'll go from there. And I don't think there'll be any huge earthquake shattering thing for those of you who have a lot of experience with solar. I'm just going to go through the basics. I'll try to keep it at an upper level. Sometimes I have a tendency to just go on and on and on and on and try to explain the whole subject to everyone. And so I know that won't work. But it is Monday night. The cool part is we do got some most of our news, strangely enough, this week is from you Australians. You seem to be very active in the news world this week, and I did a double search, or should I say I had ChatGPT do a double search, and confirm that these were all of the top articles, and they absolutely are. So we'll just get into them initially here right off the bat. Uh, Free solar power for Australian households. It looks like New South Wales, Southeast Queensland's, and the South Australian will receive at least 3 hours of free solar power daily starting in July of 2026, even for those homes without rooftop panels. Now, what this feels like to me is that the government-sponsored solar power generation is basically overproducing. They can't use all the power that they've got, so they've decided that they're going to give back to the community and give it all back. It's interesting because this will, in my mind, this changes how you think of battery power. Because if your power is free, then what does that mean for battery power? If you get, let's say you get power for 3 hours, and this reminds me of those folks in Texas who have those 3 hours in the middle of the night, the 3 hours, 5 hours, something like that, and they had that time in the middle of the night to basically charge their batteries. And so what they do is they crank it up during that time, and then they just go the rest of the day without it. And then, of course, they have some solar help during the afternoon and day. This would be interesting, different kind of formula, but it's going to be interesting to see how it goes. Because, I mean, you're talking 3 hours of power. You could literally have I guess it's a solar system where you could take that power from the grid, put it into your batteries, and run your household. And then when that time ends, then you could use that power for your peak hours or for the rest of the day or whatever the case may be. It'll be interesting to see how this changes things. Would you even need panels if the panels, or if the government's providing the free power, or the electric company's providing free power? And I don't know how the electric companies operate down there. Are they government owned? Are they independently owned? But this kind of brings us to the second article, which I think may end up going hand in hand, because another Australian, the source, the first one was The Guardian, for those of you that are interested, and the second one is from The Australian. And this one talks about Meadow Creek Solar Farm, including a 250 megawatt battery system, was approved despite over 500 local objections for environmental and land use impacts. So here we have Australia again pushing the solar project scale to the larger thing. Now, whether or not this is just an overreach of government authority, in spite of the local population saying, look, we don't want the environmental impacts, or whether or not it's something else, I don't know. But it seems like that may kind of be connected to the previous story where they're thinking, okay, we can't use all the power, so we're going to give it away. And if we can't sell it all and we're going to give it away, then we're going to also invest in some batteries to do it. But this one does say the Meadow Creek Solar Farm, including a 250 megawatt battery system. So this seems like it's a new farm along with a battery system that's going to be added. So that's interesting. And then third is legalities of a DIY solar installations. This one was from SlashGear, and it basically is an article that covers the legality of installing solar panels, solar yourself, and touching on building codes and permits and inspections and liabilities, which is a long interest of my own. I don't know that many of you are aware of it, but I have started a DIY solar class, and in that class I'm teaching a lot of the code requirements and stuff like that that you would need to follow in order to make sure that you're code compliant. Now, I myself am not an electrician, but going through a lot of the certifications for installations and for selling solar and setting up and configuring and all that kind of stuff, you find a lot of this type of information is kind of interesting, and it's very interesting to me anyway. So that's kind of the news this week. So let's get straight into the basic solar system. I am going to just kind of draw it up here on the board, and I've got my some notes with me here. So if you see me referring to my notes and trying to figure out what the next piece is I'm trying to keep this as organized as possible and try a little to stay on subject and to stay on the content on subject. So let's talk about solar system overview. Now, in my mind, the solar system has two main areas and four major components. The two main areas are your DC side of your solar system. Some people only run their solar system with DC power. For example, if you wanted to run an RV and you only wanted to run the basic lights and you had a DC refrigerator, a DC powered refrigerator, you may get away with only a solar system that only has the DC powered stuff. A majority of us, though, use the solar system with the other half of that system, and that involves an inverter to convert that DC power to AC power. And this is where a lot of people start getting things confused, and they start confusing the power sources. So we're going to start on basically on the DC side where the sun comes in, and we're going to track it all the way to you plugging in a device on the AC side, and I'll cover all the pieces in between also. But let's start off with a few components here, and I'm going to try to keep my colors straight. I have for yellow and orange for my solar. So I'm going to start off with some solar panels, and I'm just going to put up 4 solar panels here at the very, very top, and we're going to basically connect these together and run these into, and I'm going to try to use blue for anything that's DC wires. So I'm going to put up here a key that says DC equals blue, and can you see that? You can, but you can see right through it. No, that's okay. I'm using a blue screen tonight instead of a green screen, so that's why I asked if you could see that. It's a little bit hard to read, so what I might do is see if I've got a different color blue that will show up here. Yeah, that one shows up. So we will use that instead. So let me just get rid of this, and we're going to call this DC circuits for purple. And then we're going to use, in addition to the DC circuits for purple, we are also going to have red be the AC circuits, and then anything solar panel related will be the orange here. And I'm going to try to keep it color coordinated to make it easier to understand and isolate the different systems as we go along, and so that you can see the wiring colors as we do this. Now, it does not mean that I'm not going to use black for some of the negative lines and green for some of the grounding wires, but I will try to keep the red for AC and blue for the DC positive, and the negative we'll use as a black all the way around as it comes in. So, and green also, because a lot of those systems are not isolated, meaning that they don't be kept separate. You keep the positive of the DC and the positive of the AC separate. In a lot of the cases, the ground is a shared ground across both systems, and so is a negative, or in the case of AC power, you don't actually have a negative, you have a neutral, which is similar but not exactly the same. Okay, so let's start off with the solar panels here, and we are going to draw the power for these solar panels that they come down and they connect to the solar panels are a chemical, and I just want to explain how these actually work. When light comes in, there is a chemical reaction with the inside them that causes a stir in the chemical balance, and that creates the electricity. There's a lot of more science behind it. I want to keep it very simple today and not make it confusing. But basically, let's just say today that we're talking about a chemical reaction to the light itself, which causes the electrons to react. And as those electrons are moved from one side of the panel to the other, those are collected and thus create the energy that you see, or that we get from solar panels. Solar panels, because we're using the purple, are creating DC power, and they are the very beginning of your solar system. Now, that would, when this goes in, the thing is when you have solar panels, it is very difficult to have a solar panel that is exactly and precisely the right size, generates the right power, generates the right voltage, excuse me, and also maintains the right current to charge the battery you want. So what they do is they create the second major device. Now we're going to talk about the second major device here. Let me label these panels. And this is the first major device. The second major device is going to be what they call the, and I'm going to put a box here for this. This is the charge controller. And it is exactly as the name implies. It takes this DC power that comes in, and it works in conjunction with your battery to produce good power to charge the battery. Now, it has some intelligence depending upon the different types of charge controllers, and we'll go over a couple of different examples of types of charge controllers. We're going to start off with a generic description here, though, and we're going to say that this charge controller, and I'm just going to put up MPPT for argument's sake right now. Now, there are two different primary types of charge controllers, and really three types. One is no charge controller at all. The MPPT basically takes the maximum power point, and we'll go over what maximum power point means. But for now, let's just say that it takes this DC power from here and adapts it down in an intelligent way for your battery type and for your battery voltage. So if you're running a 12-volt battery, that's obviously a lot less voltage than it is a 24-volt battery, and that's even half of what a 48 volt battery is. So it's going to do that smart adaptation of that voltage, and we'll walk through an example of how it does it. But this brings us to the third component, which is the batteries. So in the batteries, you also have a positive and a negative. Now, regardless of the voltage of this battery, the way the flow of this works is still exactly the same, regardless if this is a 12 volt system, a 24 volt system, or a 48 volt system. The wires may change, the fuses may change, the equipment itself, some of it may change, the way you run the panels may change, and the battery obviously will change, but the theory remains the same. So this is the basic concepts at this point, and then we're going to go back and add some additional pieces to it. Now, keep in mind that the purple line here, this is your MPPT, and we're going to say that, for example, today, or for right now, we are looking at a 12 volt system. So whatever power comes in from this side, and let's say, just for argument's sake right now, that each of these are 30 volts. So that means that you have, and I probably should give you a little bit better view of that. Let's see if I can do that. No, I can't. So you can see here from this that this is 30, 60, 90, 120, and the way we have these arranged in series, meaning the panels are connected to each other, the voltage adds together. So that means this is going to be feeding 120 volts of DC power to your MPPT. Now, your MPPT needs to have a couple of things in its configuration. One, it needs to be able to accept the amount of voltage that you have in the panels being sent to it. And two, it needs to be adaptable to the voltage of the battery that is going to be outputting here. And then it should be able to handle the amount of output that you want for this battery. Now, in this case, we're talking about a 12 volt battery. So what it will do is it will step this down from the 120 volts to the 12 volts to the exact charging profile for the battery that you have. Now, let's talk about lithium iron phosphate batteries. They are by far my favorite. So they are the ones that I am going to refer to, and that's the lithium iron phosphate batteries, or LiPo. These batteries have a very distinct charging profile, and that means that you charge at 14.4 volts, and they operate at a normal 13.2, let's say. So this is a charge, and this is an operation. So what's going to happen is this charge controller knows this. Now, there are some additional configurations here, but I'm going to keep it simple for now, and we'll go back and talk about a few of them as we go through this. So what it is going to do is it is going to look at what comes out of this up here, and it's going to convert it to what goes in down here. Now, the nice thing about MPPT is it does an exact conversion. So if you have 120 volts going in, and let's say that each one of these is a 200 watt panel, we're going to talk about ideal circumstances where it's going to output the actual 200 watts that it labels here. So that's 2, 4, 6, 800 watts at 120 volts. Now, this is maximum, not ideal. During the day, the sun comes up and the sun goes down, and it's not always pointed at exactly the right spot. So you can't count on that except for that peak moment during the day when you get the perfect alignment with the sun in order to get the 800. But we're going to do, for purposes of explaining the system, we're going to work with the 800 that's here. Now, I'm going to pull out my calculator here so that we can work whatever math we need to work. So if you bring in 800 watts at 120 volts, what the MPPT, the nice thing about the MPPT is it can use Ohm's law to translate this from 800 watts at 120 volts, which if we take 800 watts and you divide it by 120 volts, you'll notice that this is running at 6.66 amps. So that is, and these numbers work exactly like that. It is watts divided by volts equals amps, or volts times amps equals watts. This is Ohm's law, and this triangle works no matter where you are. And if you're going to be working with solar, this is the basic formula that you're going to want to learn no matter what you do, because you're going to need it at practically every aspect of a solar system, from calculating panels to calculating what your inputs and your outputs in PPT are, to what your battery is. And then later when we get to the AC side of things, you're going to want to know it there so that you know how much power you're going to have and what you're going to be able to plug in and what you're not going to be able to plug in. So let's talk about what the MPPT does. Is it takes Ohm's law and it translates this into exactly the same numbers, but just using it. So using it differently. So if we translated this into 800 watts, or excuse me, 120 volts, how many amps would it need to be to still equal 800 watts? And that's pretty easy to figure out, because we know that the charging rate that it's going to be sending, and let's just say that it's going to send it at the charging rate of 14.4, and it's not going to be the 12 volt, although a battery is called 12 volt. Keep in mind that lithium iron phosphate charges at 14.4, and most of the nominal operating is at 13.2, and then it can go down to about 10. So you're going to be operating with more or less amps based on where the actual battery voltage is. Now, it will spend most of its time at 13.2. So that's usually the number that you use to calculate what you're going to be doing. So we're going to use 13.2. So if we have 800 watts, 800 watts, and instead of dividing it by the 120 volts that it was coming in here for 6.6 amps, we're going to divide it by 800, divide it by the 13.2, and it's going to be 60 amps. So that means that the same 800 watts, because if you take this formula, which is volts, which is the 13.2, 2 volts, times the amps, which is 60, equals the watts. So we can use this one to determine that those watts converted to the MPPT's output to this battery would need to be 60 amps, and that 60 amps would in turn still equal the same 800 watts here as it came in. This is the beauty of the MPPT. It takes the maximum power that it can get from this, and it converts it to the maximum, the power that it would need to put into the battery. Now, as the battery's voltage goes up and down, the number of amps would obviously change. So for example, when the battery is almost full and it's sitting at 14.4 volts, we take that same calculation of 800 watts divided by 14.4, and it's only going to be 55.5 amps. But if you take that other side of that and you say the battery is almost dead, and let's say it's at 10 volts, then it would be 800 divided by 10, it could be as high as 80 amps on this side. So this wire that is going to be connected from this to here is going to need to support the highest voltage or the highest amperage of all of these, plus whatever leeway, and we'll get into the leeway and we could talk about that more later. But right now, understanding this is the range that we're talking about, between 55.5 and 80 amps of operating amperage coming from these panels in ideal circumstances. Now, there's a whole bunch of other if then buts that we need to take into consideration. For example, panels voltage increases when weather gets cold. It decreases when weather gets hot. The panels can also overproduce what is here because that is the ideal circumstance. It's not the maximum that it can produce. And so you want to make sure that you can take all of that into account when you're working with wire sizes to get all the wire sizes. But for now, to understand the three basic concepts, the first one is you're going to take the panels and basically figure in and take them, feed them into an MPPT, which is a 12-volt charger. This charge controller will then smartly send this voltage over to your LPO or your LiFePO4 battery and your lithium iron phosphate battery. This battery will then charge up, and it will be smart enough to go into a third configuration that it have over here, which is what we call a float. Now the float value, and that's the wrong blue, it will just disappear on your screen. Put this one here. The float value is for when we get the battery all the way charged. You don't want to leave it sitting way up at the very top. It's kind of like driving a car. If the fastest you can go is 100 miles an hour, the last thing you want to do is sit on the highway for 9 hours going exactly 100 miles an hour. It's very stressful and you're bound to make a mistake. So what you want to do is you want to back off of it a little bit, and you may want to only cruise at 80 miles an hour or 60 miles an hour in order to make it more constant charge voltage as opposed to the while I'm in the process of speeding up. So the same thing holds for a battery. So you'll back the float off to, and it's usually, I think it's 13.6, 27.2. Yeah, so 13.6 is, I think, the typical float for a lithium iron phosphate battery. And then, of course, 10 volts is dead. So you've got all of these voltage ranges that are fairly well known, but the majority of the time, these lithium iron phosphate batteries, they start here at the 10 volts, and they kind of go like this up to the 13.2, and then they go like this to the 14.4. So this part here is, 80 to 85% of the battery's time is spent right here in this nominal 13.2 voltage. Now, if you're looking at a 24 volt system or a 48 volt system, you can take all of this math, and for a 24 volt system, you just multiply it by 2. And if you want 48 volt system, you just multiply it by 4. So for example, the charge voltage for a 24 volt system would be 28.8, and the charge voltage for a 48 volt system is 56.6. So, and it's just this times 4, it's just this times 2. Whatever voltage you want or you need for your system. And this is usually the deciding factor, is what amperage does it take to get that power from here safely to down here safely through these wires. And this amperage is what you're looking at to decide what size wires you need to make that happen, and what size charge controller. Because a charge controller that can do 60 amps isn't very difficult, but you're still talking about a very small system. If you had if you had 20 panels, it would be very difficult to get within a charge controller without using multiple. Whereas if you go up to a 48 volt system, you could find a charge controller that at 48 volts would be, this could handle 4 times the voltage here, meaning 1600, it could handle 3200 watts of panels for 60 amps very easily. So this is the basics of the DC side. Now everything that we've talked about from this point up is all on the DC side of the system. Now if you are hooking up a couple of lights, a DC powered fan, a DC powered refrigerator, anything that doesn't require an actual wall outlet plug-in, then this is all you need. You need these 3 basic components along with some safety devices. Now, please do not misinterpret me. There are fuses and breakers and all kinds of stuff that needs to go in here to make this safely operational. And we can get into those pieces in later videos and more description. But I want you to understand these are the three basic components that you will find in every solar system that is operating without grid control. Now, there are some that are on the grid, that are grid tied, that don't require batteries, and those are completely different, and they can operate completely different, or they can operate the same. But we're going to say that they're a different kind of beast. This is a basic system. If you wanted to hook up a little system to run a light or a fan, this is the type of system that you would need. Now, let's move on to the fourth basic component before we go forward, that talks about the AC side of things. So most of us are going to want to plug in AC powered devices. Whether we're going to plug them in, whether you're going to have a mini split, whether you're going to have a washing machine, or you're going to have some cooking utensils, a heating pad, in my case a coffee pot, or something along those lines. I love my espresso machine, so it would be the espresso machine. All right. Sorry about that, guys. I just realized that I wasn't even live, and I have gone through half of the solar system already. And then I look up and I notice that that I am not even live. So I'm going to do a quick recap of where I am and focus on that, and then I will. It's just a darn shame because I've gone through a large portion of the DC. So let me go through it again for you and highlight what we're doing this week. So this week, the focus is on the very basic solar systems and the major components that are required to connect a solar system. And I want to go through each one of them and explain where and how they're used. So a few things that I've done with the chart here, and I will walk you through it as it stands now. Anything that is labeled in purple here, and so far all I have done is work with the DC side of the solar system. There are two major sides as I see it, the DC side and the AC side. Now I am talking about specifically not grid-tied systems. These are either hybrid or with battery systems, and they are hybrid or off-grid type systems. So I started with the orange is highlighting the panels, and in this particular instance I show there are 4 basic panels that I have configured here in series. And when you configure panels in series, now keep in mind that solar panels are where the beginning of the solar system starts. A solar system starts with the sun providing you energy, and I'm going to walk you all the way through you plugging in a device and those intermediate places where you may not even want to plug something in. You may want to just use battery power, and that's okay. I will show you where you can stop the system and build just that piece of it. But we're going to start off for basic concepts of the 4 different solar panels here. And with these solar panels, they are 30 volts a piece, which add up to 120 volts. They're producing 200 watts a piece for 800 watts, and that creates 600 amps. I briefly describe Ohm's law, which is very important for anyone getting into solar, and you're going to want to understand this concept no matter what you do. This is very simple. This is watts divided by volts equals the amps. So as you can see here, I've taken 800 watts, I divide it by 120 volts, which is what these 4 panels in series are producing, and that creates 6.6 amps. Now, the second major part of a solar system is what is called the charge controller. Now, there are a variety of charge controllers on the market. The one I'm going to cover is the MPPT today. There is, however, other ones involved, but we will get to them later. All right. So that said, this is the DC side of things, and I have covered from the beginning where the sun comes in, and I might even put a little sun up here. It rains down on these panels, and that the panels in turn convert this to power. That power is thus sent to the MPPT controller, which is a charge controller that is smart enough to recognize the difference in the different batteries. It has a programmed configuration for whatever battery that you have and whatever profile that you are looking for, and that sends the electricity to the battery. So far, everything that we've covered here is basically covers the DC side of a solar system. We've covered the maximum and the minimum amperage of operating amperage, not the other considerations to take into like temperature or spikes or anything like that, but at least we've covered the basics of operating amperage that you will need to have. We've also covered the battery and the charging profile. Now, most of us are going to want to run AC devices. You're going to want to plug something in, whether that is a curling iron, whether it is a cook fryer or an espresso machine or a coffee pot or something that you cannot get on the DC only side. And I sympathize with that, and so does everyone else, and that is why they created the fourth major component on the AC side here. Now this is the first component that is truly AC side of it. Now it does reach over to the DC side and use the battery power, but it is not part of the DC side. So let's talk about this. The inverter is what it's called. The inverter does exactly what it talks about. It inverts the power that you get from a DC circuit into AC power. Now, what does that mean? That means that it is taking the power that you get from here. This connects to, on the DC side of the inverter, the DC comes in this side, and then it goes out, and as we discussed, we are going to use red for AC power. So then you have an AC out that in turn creates either 120 volts AC or 240 volts AC. You can also hook it up in three-phase and do larger builds, but for the simplicity's sake, we're going to stick today to a very simple 120 volt system that you can plug standard household devices in. If you need to run larger ones like AC for washers, or not for washers, for dryers or for hot water heaters or things like that, you can do it. But for the simplicity's sake today, we're going to talk about this going to a wall outlet that is going to provide you, see about my artwork here, with power to run a device that you want to plug in. So this is when you've taken the power in here from the panels, you've run it through the charge controller, which is the second major part. The third major part that you built on is going to be the battery. And then the fourth component is going to be the inverter. Now, these are the four major components. Now, this is the AC side of everything, and everything above this line is DC power. So it's very important when you're working with a solar system that you distinguish between the DC powered outlets and the AC power outlets. Don't get them confused, and for most cases, code requires a lot of separation between these two, running them in separate raceways, running them in separate tracks, running them in separate things. There are some mixture that can be done, but in a lot of cases you do have to separate them. Now, with this inverter, it is going to take the power that the solar panels have given to the MPPT. The MPPT is converted that power to the power that matches your battery, caused your battery to be charged. Now it's going to use that power to invert that power from whatever DC battery source you have into AC battery source. Now, these four major components are what you're going to need to put together to build a solar system. Now, please do not assume that these are the only four components that you need. And what I will do is I will go in here and I will try to highlight some of the key points that make this thing. There should be a off-on switch here. There should be a fuse here. Most likely, there's also an off-on switch here. There's certainly a fuse or a breaker box here. There's almost always another fuse along the line here. So you're talking about many different safety devices that are here to prevent disastrous results from happening. You need to make sure that the lines from the PV has a shut off so that if something goes wrong and you need to turn it off, you can do so. You need to make sure that the power coming from the MPPT into the batteries, that you can shut it off in case you need to work on the system or in case something goes wrong with the batteries and you want to shut down that power. You need to make sure that it's fused so that if something happens and you're not the person turning it off, that you can that it will automatically pop the fuse and protect the wires. Keep in mind, all of the fuses along the line here are there to protect the infrastructure, and not necessarily your equipment. They're there to protect the wires from melting and dripping down and then all shorting out and causing a massive fire because you don't have it fused. If you have it fused, when it exceeds the capacity of the wire within the circuit, it will automatically pop that circuit and protect the system from a catastrophic failure. And that is why you have these safety devices here. Yeah, sure, some of the shut-off switches for maybe the PV, maybe that it's code required that you be able to shut it off at the facility. But that doesn't mean that if you weren't going to want to work on this, that you don't need a way to do it. So most of them, even though they're required for that purpose, doesn't mean they're not required for the purpose of you using the system on an everyday basis, or in the case of something going wrong. I can't tell you how often I use the shutoffs that are here and the fuses. Now, I've been fortunate enough that even though I've put all of these safety features in place, I've never had any of them actually prevent anything major because I've never had anything major happen. But I can tell you it only takes one of those events to where you want to do it. Now, that said, I do need to put a disclaimer here. I am not an electrician. I am no substitute for an electrician, and I am no substitute for an engineer that takes and improves a process for you to build a home system. I am a DIYer just like you. I want to show you the major components that are here to educate you on what they are and to teach you how to use them, and I'm showing you how I use them. So please keep that in mind when you're doing this. Electricity is dangerous. Treat it with respect or it will bite you, and I don't want anyone getting hurt. Okay, so with these four major parts, you're going to need to understand when you're building this system. Now that we have the four major parts laid out, let's talk a little bit about sizing of those four major parts and where that sizing is going to come from. So in that sizing, you're going to want to size the panels to the power that matches the voltage and the wattage to match the MPPT, and you're going to need to size the MPPT for input voltage and output amperage for the right battery that you have here. And then you're going to want to size that for the battery based on the inverter and how much power you're going to need to provide to your AC devices and how much power you're going to need to bring in over here in order to determine what voltage that you need. So there are a lot of different sizes, and that is where you're going to want to possibly consider further education, and I encourage you to look at the DIY solar class that I have available. And this kind of highlights the basic system that you have. if you are interested in building a system like this, I will, in the next day or two, I have a couple of different, actually I have a video out now. I will put a link to my solar shed, which highlights a 12 volt system just outlined, just as it's outlined here, that you can use for parts to build it. And I hope this helps with your building a system of your own. Now, I did receive quite a few questions leading up to this show, and I do want to go through some of them and see if I can get them to appear on the screen here. Let's see if I can do this. There we go. So I'm going to walk through a few of these questions, and if at any time you have questions, please put them in the comments, and I will make sure that I stop and handle them also. But I do want to go through these questions before we finish the show up today. All right, so here we go. We are going to start with question number 1 from Alex R. from Texas. Ask, do I need a fuse between my charge controller and my battery? And the answer is absolutely yes, you do need a fuse. You need a fuse on practically all of your DC circuits in here in order to prevent, as I said before, in order to prevent the wires from being damaged. And I'll give you a perfect example of where this could go terribly wrong. First of all, if you are overfeeding, and something goes wrong within your MPPT, and you were overfeeding your battery and causing a massive current influx to it, it would be very detrimental to your battery and could cost you a lot more than just a bad charge controller if it didn't do it. But assume the opposite happens and something happens with your MPPT, and now your battery backfeeds massive quantities of electricity to your charge controller, could cause your charge controller to burn out, catch on fire, and cause massive disaster. So absolutely you do want a fuse in there. I would suggest not only a fuse, maybe a breaker that you could use to turn it off and on, and that would act as a ability. But you need to make sure it's a DC rated breaker that is a good quality breaker that doesn't cause you problems. And I'll link in the description some breakers that are safe to use here. But you absolutely do need a breaker for that, or you do need a fuse for that. There's no question there. Next question is from Megan L. Ask, what happens if my solar panels are wired backwards into the controller? In some controllers, it will burn them out. Some of them will simply give you an error code and do nothing, and some controllers will simply ignore them when the power is on the wrong side. It depends on the device itself and what it is. I've seen like 6000 XP from EG4 where it basically just does nothing. It gives you no errors, but it doesn't work. My suspicion is it shuts a relay off when it's wired backwards and prevents it from harming the system. Very fortunate for those of you who have done that with them. I've seen with Victron's systems that it basically prevents it. I've also seen others complain that it burned out their system because they hooked it up backwards. Polarity is extremely important when it comes to breakers, fuses, inverters, batteries, charge controllers, and your solar panels. All of them is very important. So anytime you're working with a solar system, you need to make sure you distinguish between the positive, the negative, or the hots and the neutrals if you're working on the AC side of things. Number 3, just curious ask, can I mix 100 watt and 200 watt panels in the same system? You can mix them in the same system. Most likely you are going to need to use separate charge controllers and accommodate it that way. But you can have multiple charge controllers. So let's say that you had a 12 volt system like you have here. We could hook up another 100 watt charger that provides 18 volts of power and put it into a charge controller that charges on the same 12 volt battery, and that would not cause a problem. So you definitely can. Can you put them in the same string? That is another question. and it's very tricky to answer it not knowing the exact panels. There are ways to do it, but it is very, very tricky to do it correctly that doesn't cause more trouble, and it's really not for a beginner to deal with. It would be more of the experienced user that would need to be wanting to play with something like that. But yes, you can use them in the same system. My suggestion is you use 2 separate controllers to do so. Next, looking for that chat window. Where did it go? There it is. Pull that over here. Okay. I lost my screen. Sorry, guys. There we go. All right. So next we have David from Michigan ask, is there any harm in leaving solar panels connected to an inverter when the inverter is off? Most likely no. I often turn the inverter off and just let the charge controller charge the batteries when I am doing battery tests to make sure that I don't have anything interfering with them. So no, it should not harm it whatsoever. Now, if your inverter is an all-in-one inverter where it's both the charge controller and the inverter, well then obviously you're not going to get any charge that way. But no, it should not hurt them to do that. Now, there are some 12-volt systems that don't require charge controllers that are a little bit more tricky, but usually you need to stay within only 3% of the battery max amperage in order for that to be okay to leave hooked up then. And then it will not stop charging, but it is more considered a trickle charge that shouldn't harm the battery. Tom S. asked, what is the main difference between PWM and MPPT? This is a good question, and I did not cover it earlier. I talked specifically about MPPT. But a very brief answer to this is, if you have an MPPT, it is going to use Ohm's law to take the 800 watts at 120 volts and convert this to the charging rate that is needed and output the same 800 watts at 13.2, creating 60 amps of power as opposed to the 6.6. It's going to find that maximum power versus input from the panels. It's going to range between the battery voltage here and the maximum power done here, and find that perfect point where it can produce the most power. An MPPT, or a PWM, is a much simpler device. It is basically going to say, I need to charge at 13.2 volts. Therefore, I am going to cut the power off at 13.2 volts, and everything generated above that just gets thrown away, and I only end up with a fraction. So for example, if I have 120 volts coming in here at 800 watts, and I reduce that to 13.2, I'm only going to get a percentage of the power that came from that, and so that would be 13.2 divided by 120 volts. I would get 11% of the power coming from these panels to feed in to this battery down here. 11%, the 800 watts, would end up being only 88 watts would make it from this setup through a PWM here, because all of the extra power would be trimmed off at the instead of using the maximum power point and adjusting that voltage based on Ohm's law. Hopefully that helps. Next is Janet asked, how do I tell if my inverter is pure sine wave or modified sine wave? There are devices that you can use, a oscilloscope that you can connect to the power itself, and it will show you the sine wave. The sine wave will look bouncing between, let's say, 120 positive and negative like this. If it's sine wave, the wave should be nice and smooth up and down, and the inverter should tell you if it's pure sine wave. If it's modified, it's going to show you the same chart, but it's going to look more like this, where it still goes between the 120 and the negative 120, but the difference is that it does it in a a very violent shift as opposed to nice smooth up and down. This is why it's dangerous to some devices, because that shift, even at 120 volts, shifts between a positive 120 volts and a negative 120 volts, giving you a jerky shift up and down all the way. And so that is really the big difference. Now, how you tell is, and this is the one thing that's very, very tricky, is an oscilloscope is the actual device that you can plug into it. And you can get them for about $80 at this point. $80, $90, I think, on Amazon. And I'll include a link down below to them a little bit later. All right, and then I lost the messages. So let me find them real quick. There it is. All right. Brandon from Arizona asks, should my ground rod connect to both the inverter and the battery's negative? And ground rod, no, it should not. All the grounds should run back to the inverter, just like they normally would, and then from there, they should be they should run all the way back to the main panel that comes in the from the power company. Now, grounding is a very tricky type of thing, but there should basically be a ground wire that connects everything together and brings it all the way back to the main panel, but it should not be combined with the negative on the battery, especially not in the battery. Now, in RVs and stuff, there are some frames. And this is a very wishy-washy answer because there is a lot of differences between these things and how they work. But in most cases, no, they should not be connected. But in some cases, like RVs, they are connected. And in some cases, they are connected at the main panel. It's a very wishy-washy answer, and I'm sorry I can't give you a better one at this point. But you said ground rod, and the answer is no, except in a very specific location, which is the first connection of the grid to your main panel. That is the only place they should connect. Mike T asks, how do I size wire between the controller and the batteries? Between the controller and the batteries is going to need to be the maximum power that this is going to output to this. So if you've got an MPPT that is output, most MPPTs have an output maximum. They'll tell you that they can input, let's say 100 and let's say they can input 150 volts, and they can output, 80 amps. You need to size the wire here to not only the 80 amps, but the 80 amps at 125% of its size. That means that you need to have a wire that can support 80 times 1.25, 100 amps. And that will ensure that this wire can support enough voltage for the 80 amp charge controller that you have designed here. Can I run both 12 volt and 120 volt circuits from the same battery bank? Yes. So you can connect and it's quite common in most RVs. They will connect the 12 volt for the lights and the 12 volt devices directly to the 12 volt batteries. Or in the case of a 48 volt system, they will step it down and then connect the 12 volt to that. And then the inverter acts just like another 12 volt consumer and connects to the batteries. Most of the time, these connections are handled through bus bars so that everything connects to a bus bar, and that includes your batteries connect to the bus bar. But absolutely, you can run 12 volt and you can run the inverter off of that 12 volt system to get to the AC side of things. Leo from California asked, how much voltage drop is too much on a solar run? And I'm assuming you're talking about up here in this run here. Standard is to not want more than 3%. And so in order to get more, the higher the voltage, the longer the run. In most cases, this isn't a problem for smaller systems because your panels are so close to your inverter that there isn't much chance of loss. And this isn't too much of a problem in larger systems because you're usually stringing multiple panels together and bringing it up into higher voltages, and thus it can go further. And that's basically how you deal with that in addition to larger wire. So there is three types of PV wire. There is an 8 AUG, a 10 AUG, and a 12 AUG. And the 12 supports the lowest amperage, and the 8 supports the highest amperage, but it also helps support the longest distance. And you can read from the manufacturer specs of that wire what the drop would be based on what you need. There's also a formula that you can use for resistance, and you can actually test your wire then. Make sure when you're using a calculation like that that you're calculating round trip, not just one way. In other words, if your panels are 100 feet away, you need to calculate 200 feet of wire, one for the trip there and one for the trip back on the negative side of things. What is, Emily W. asked, what is the safest way Sorry, I'm trying to see if I can get this chat window to show up here. I don't know why it's not. There it goes. Okay. What is the safest way to connect multiple batteries in parallel? Parallel batteries, the safest way is to fuse each battery and then have the batteries connect to a bus bar and then use the battery power off of the bus bar. That is the safest way to parallel batteries. There are a lot of people that run positive to positive to positive or negative to negative to negative, and under a very small battery bank of 2 batteries, maybe 3 batteries, you can probably get away with that. But my suggestion is that you run, especially when you get into the larger systems, especially in systems that are 12 volts where you're pulling large amounts of energy for, under a couple hundred watts, it's no big deal. But when you start getting into 1,000 watts, 2,000 watts, your amperage starts to go up, and you don't want that traveling through the combined amperage traveling through those connecting circuits. You prefer to have each battery operating on its own and each battery being fused independently also. Let's see. Next is Bruce asked, can I charge my batteries from solar and shore power at the same time? Yes, you absolutely can. DC powered devices can have multiple inputs. There is no synchronizing of the wave sign and like there is on the AC side of things. So you can have multiple charge controllers, you can have battery chargers, you can have multiple devices all inputting into the batteries at the same time. The one thing you want to be careful about is, let's say that you have a 12 volt battery that has a 100 amp maximum input. You don't want to input more than that battery can withstand. And that means that if you have one charge controller that's 80 amps and another that's 80 amps and they could input 160 amps, it could be a very bad day if you start putting 160 amps into this battery and there aren't the proper safety devices in place. And that's why it's very important that you fuse every individual battery, because even if you have 5 batteries connected to a bus bar and you have enough power coming in to supply all 5 of those batteries safely, if 3 or 4 of those batteries for some reason are taken out of service, whether that be something bad happened, the wire gets broken or cut, or they short out, or whatever the case may be, you want to make sure that if the only battery remaining is the only battery there, that you don't lose it also because too much voltage or too many amps get pumped into it. You want to make sure that it has a fuse on it also to protect the voltage power coming in and to protect the power going out. You don't want to have an inverter kick on and try to draw 300 amps from this battery that can only support 100 amps. At the same time, you don't want multiple charge controllers pumping in more power than it can take. So it's a double-edged sword, and that's why you want to fuse all of your batteries independently. And I suggest that you connect them up to a bus bar, and then it is safe to use multiple chargers at a time, but just be very cognitive of the consequences of turning batteries off for maintenance or for when something goes wrong. How is your system going to react to that? Some systems can accommodate that type of an environment. For example, I know that Victron's communication is really good, where it takes all the batteries into account. They all communicate to a central uh, 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 servo GX, and the GX tells the chargers and can communicate with all the chargers to say, hey, here's the maximum amperage that we can provide together between all the banks. And when they start, and if a battery falls out of that or whatnot, then it can cut that out of the allowed amperage to go in. And that would mean that if I had 5 batteries sitting at 100 amps that was allowed to be charged at, and one of them disappeared, it could say, okay, we can only send 400 amps at that point. So there are ways to deal with it, and that is one of those ways. And other systems can do the same. The EG4 batteries can do the same. They have the communications, and lots of them can do it. But that was just one example of it. But yes, you can charge your batteries from solar and shore power at the same time. How can I tell if my panels are really producing their rated watts? There are a couple of different things that you can do. One is you can buy obviously a tester to just plug into the panels and give it the ideal circumstances and see what it produces. Two, you can, I got a video coming out on a little device that I built that looks like this. And basically with the parts, oh, the screen fades away. Sorry about that because of the background here. But basically with the parts from this, you can plug this in line to a solar panel, and I use this to measure the output of an individual panel. Now, usually I use this for measuring multiple panels, when I have multiple panels connected, to find out if one or the other is producing what it can be, but it can also be used for a string. I think this one is it's 200 amps, 100 volts max. So I could measure strings with this one, which is why I bought these, and then I connected these ends onto it so that I could just plug them in and test certain panels. So you could buy something like that. But they do sell actual testers to plug in a panel and test it. I've also got a video out that allows you to test the volt, that shows you how to use a simple multimeter to test the voltage and the short circuit current, which should give you a rough estimate of what it would be producing. Would it be that? Keeping in mind that there is some degradation and loss over time with solar panels, so keep that in mind. But that's the easiest way to do it. And a lot of, especially new people, when they get involved with solar, they don't understand that the rating of these panels, if it's a 200 watt panel, that means under ideal lighting circumstances, you're going to get 200 watts out of it. And it's very rare that you get exactly 200 watts out of a panel, that you get 100% production. When the sun comes up in the morning, it's going to slowly rise and get to that perfect place. And if your panel is pointed exactly at it at some point, you may get that maximum production. But usually that doesn't happen. So a lot of the times the common problem is that you're just expecting more from it than you're expecting this maximum output, as if it's a device you plug into a wall and it gives you a certain amount of energy. Unfortunately, solar doesn't work that way. It depends on how much the chemical reaction based on the amount of light, how much energy it can produce. And that means the more light, the more it produces. And the maximum output that's listed on the label on the back is in fact the maximum ideal circumstances output. Jill from Oregon asked, what's a good rule of thumb for fusing on 12-volt systems? Fusing, and I guess the question comes down here is, I fuse practically every circuit, and I try to fuse some of them even in both directions. And what I mean by that is let's say the battery from the actual battery itself, and then maybe the inverter may have a circuit breaker in it also. And that allows it to measure the current in both directions and the maximum pull on them. That's ideal, but it's not ideal all the time. But the one thing you do want to make sure that you're doing is that each battery should independently fuse or breakered to protect it. And this applies when there's only one. You want to protect it from being shorted out and doing it. When there's more than one, you want to protect it from being shorted out, first of all. But second of all, if multiple of those batteries stop working, shut down, have overvolt protection or something like that, it may be the only battery left in the system, and it may have too much pull from it or too much charge going into it and cause you problems in that way. So independently fuse each battery first of all. I run all of my batteries into a bus bar, and then the bus bar goes to a shunt, and then on the positive side, I run all the positive to a bus bar, and the bus bar goes to another bus bar that's the distribution. I call it the distribution bus bar, and that one has a fuse in it. And that allows me to basically measure the input, the in and out going to the battery from all of the devices, but it also allows me to fuse the total voltage coming from the system here, and it allows me to protect the batteries themselves against that total voltage. I may say the system itself, the wires here can support, let's say, 200 amps, but this battery itself may only be able to support 100 amps. So in that case, I need to protect the wire versus the 200 amps, and I need to protect the battery from 100 amps of usage. So that's basically the good rule of thumb that I use for that. The inverter, I usually run a separate fuse or breaker for it because I want to make sure that, and most of the all-in-ones that I use have them built in, but if they don't have them built in, I like to protect it against special shorts and stuff also. Inverters, because they're converting from AC to DC, the worry that I have is some bleed over and stuff like that, so I will usually put a protection on this of 120% of its maximum pull. That means if it can pull 1,000 watts, then I'm going to put a breaker on that can support 1,200 watts. And then I size up to the closest rating from there. On the solar panels, these, a lot of the times the shutoff switch is enough. If you've got one string, they usually will not need to be have fuses on them. The biggest fear of a solar panel is that if let's say this panel starts to have problems, is that other ones in this same group of solar panel, in another group of panels, would feed electricity back to these and cause these to continue shorting out. If this is the only one with a short, then it would just shut down, and the end of the fuse would, the short would be over, and it would never actually blow the fuse that's over here. But what you don't want is another string or two strings or three strings of panels, and those three strings providing power to that short over here. That would be really bad, and that's why you're going to be fusing them. Hopefully that answered the question and maybe a little bit more. But the 12-volt system, please make sure you have the fuses at the batteries themselves, at the usually a breaker at the inverter, and the overall power here. And if you have more than a single string running in parallel, you're going to want to have a fuse up there. And that should, then of course on your AC side, that wasn't really the question, but I always, that usually goes into a breaker box and controls the main power line coming in as breakered, and then each individual circuit. And then of course there is a lot of other safety features that need to be considered as far as GFI, as far as ground fault, that's the ground fault protection. There's also arc protection up here where it senses that there is an arcing going on, and this is more common in your PV side of things where you have a loose connection and it can sense that power is jumping across the connections, especially on your high voltage DC lines, and then it shuts down based on that. That's usually, I've seen the arc protection more in your all-in-ones where your PV is connected here and you're running in, 200 or 300 volt PV lines there. So there are a lot of safety devices there, but fusing on 12 volts is very important that every single battery gets a fuse at the absolute minimum. Sam B asked, should my inverter be on the same ground as the chassis of my RV. And I'm going to answer this with a lot of questions and a lot and I don't mean to beat around the bush here, but I want to be very careful in how I answer this. It depends on your inverter. It depends greatly upon your inverter. Every inverter not every inverter, a lot of inverters handle grounding differently. If you're working with an RV, there are certain certifications that talk about grounding and how it's managed and how they would. For example, some inverters need to have shoreline power grounding or made more for permanent fixed locations and technically aren't mobile devices and will need to be ground from the thing. I have a 6000 XP, which is not made for a mobile installation in an RV. Now, the grounding that I use is I have two different ways of grounding it. If I'm at an RV park, then I use the shore power and the ground connects there and goes there. If I am off grid, then I do have to do a bonding of the negative and the ground within my RV in order to have my grounding done properly there. But because the inverter does not manage that independently, I have to manage it independently, and it becomes more of a pain than it is. For example, there are some devices like the Victron devices, which are specifically made for RVs, and they manage this grounding in a much better way than you would with a device like that. So the question is, should it be ground to your chassis? In my case, it is. That does not mean it is the right case for you. Grounding, if you're grounding is something that an electrician will need to really be involved in making sure you have the correct configuration if you are unsure of how to do it. And I am no substitute for an electrician that could help you with that question. I can only tell you what I've done. Next, is 10 AUG enough for 40 amp solar controllers? And I'm assuming that you're meaning for the PV wires that run from the panels, and depends on the brand. If it is pure copper, most 10 AUG is rated for 50 to 55 amps, and so the Beretta PV wire that I use can handle 40 amps. But that does not mean that yours can. You need to look at this very specific specifications of your wire. The size should be able to handle it, but that would imply that it has the proper insulation and the proper copper, and that it is good quality PV wire and not just some no-name PV wire that is not near as good quality. Olivia from North Carolina asks, what causes a battery to stop charging even with sunlight? 99% of the time, your battery's full. And then there are other circumstances, but my suspicion is that your batteries are just full. You can have an arc protection fault that can do it there. You can have the shade, or you can have a under voltage situation. And what I mean by under voltage is, if you have, let's say, a 6000 XP, I have a minimum operating voltage of 120 volts. And that means that if I have a couple of panels that get shaded and I don't bring that voltage up over 120 volts, then I'm not going to get the voltage that I need to cause it. Now, that isn't really fit into the scenario that we have here, but that would be what I would suggest, is that most of the time your batteries are full. Usually, if that's not it, then I would look for an under voltage or an over voltage. Because if you've hooked up too much power for the input of your MPPT, a lot of them will either shut down or you will fry them and they will stop working. Trevor L. asks, do I know if my solar array voltage is too high for the controller? How do I know? First of all, you always put a meter on these before you ever hook them to your MPPT, and then you do the winter calculation for your area based on the coefficient of your area. And that would mean that if you have 120 volts coming out of this. The good rule of thumb is that your MPPT controller should support about 20 to 25% more than it has here, and you can pretty much call it safe for most environments. But there is a way to calculate the exact voltage that you will need to make this safe, and you use the solar panels label highest open circuit voltage, and you use the coefficient of a greater than, or how many degrees and how cold it is in your area, and that will allow you to calculate the max. But if you want a quick way, use 20% of this, which if this is generating 120 volts, and you add it 20%, that would put you at, add 24 volts to this, which would put you at 244, which would still fall within the 150 volt range here, and it would be safe. That is the easiest way of doing it, but it's not guaranteed to be right because the colder your environment. Now, I'm in Florida. I don't have to calculate the cold because it just simply never goes below the actual minimum that would need to be here. But it can, for some panels in some areas, be quite a difference in voltage drop. As I said, it can be, in this case, it could be as much as 24 volts difference, and that could be enough to put you over the limit, especially if you were operating at 120 volt 120 volt inverter, and this was, you put a meter on it and it was running at 118, and then it gets cold one night and you burn your inverter out or your charge controller out. That would be bad. Can I mount solar panels flat on my shed roof, or do they need to be tilted? You can mount them flat on the thing. They don't produce as much. If you usually pointing them towards the sun, you can produce as much as 20 to 30% more power. But yes, you definitely can mount them flat if you're interested in having them attached to the top of a shed. I've even mounted them sideways on my solar shed. So yes, they can be done. Is it ideal? No, it's not ideal. Ryan from Canada asked, does the cloudy weather damage solar panels or just lower output? As far as I know, it would never damage the panels. It actually probably does less damage. Solar panels are harmed by the radiation and the ultraviolet rays. They love the light. That's what they're converting, and that's what they live on. But the actual radiation or the sun rays, the radiation side of them, it actually harms them over time, and that's what causes the degradation. So no, it just lowers your output. Do I need a breaker between the inverter and the AC panel? Yes. Between the inverter and the AC panel, between here and here, you definitely need usually it's a distribution panel that has a main feed breaker that comes in and then an individual circuit that goes out. If you are only feeding one outlet, like I've drawn here, then you still need a breaker. You still need something that could keep you from dead shorting this and melting all this wire. Keep in mind that that breaker needs to be sized to protect the wire, and the wire needs to make sure that it's the right size for the breaker. 22. Sandy M asked, what is the best order to connect a new solar system, panels first or battery first? What is the best order to connect a new solar system, panels first or battery first? You always connect the batteries first. And the reason being is a lot of the MPPTs will, especially your Victron devices and a lot of your other ones, will adjust their voltage and allow you to configure them based on the battery connection. If you connect the panels first, you could have the wrong voltage and you could cause damage to your battery by trying to charge your 12 volt battery with 48 volts or whatever the case may be. Always connect your battery first, configure your MPPT, then connect your panels after that. Isaac from Florida asked, should my inverter always stay on, or can I power it down at night? You can power it down at night, and most inverters have either a sleep mode or a low activity mode, where you can say if it's under 15 watts to just shut off, and when it detects a device come on, then it can automatically turn on. It's a great way to get rid of that idle consumption, but it does have some downsides. One of the downsides is that really low idle devices like Shelly devices that you can control with your home assistant or something like that, they don't work because they're such low idle and using megawatts instead of not megawatts, milliwatts. They're such low voltage, they aren't going to trigger the device to keep the inverter on, and the inverter will shut down. But it is great if you're just got lights in a shed or something like that, and you just don't want to pay the cost of having the inverter run all night. Absolutely. I do that quite frequently in the solar shed, especially when I'm testing batteries. I'll shut the inverter off, or I'll turn on the auto sensing to 15 amps or 15 watts or 30 watts or something like that, so that it can just automatically turn on when I hit a light or something like that. What is the difference between system voltage and panel voltage? Um, so the difference between system voltage and panel voltage, the system voltage is the battery's voltage. So in this case, in this diagram that we've drawn here, this is a 12 volt system, meaning that it has a 12 volt battery here. Now, that doesn't mean necessarily that it runs at 12 volts. It has a charge rate of 14.4 volts, an operating voltage of 13.2, a float voltage of 13.6, and a dead voltage of 10 volts. So that is the actual voltage of the system. The panels, as you can see, each one of these panels provides 30 volts, and combined in this string, they're producing 120 volts, and that runs into the MPPT charge controller. So the panel voltage and the battery voltage are two different things. A long time ago, meaning a few years ago, 12 volt batteries had 12 volt panels that you could hook up, and they basically had a small trickle charge that people would use without charge controllers. And you can still buy trickle charges. I've done a couple of reviews of trickle chargers for boats and car batteries when you're out of town and stuff like that, that trickle in less than 3% of the battery's input voltage or input amperage. So if you have a 100 amp battery and you have a 12 volt battery, then it would need to be less than 36 volts. And it just trickles a small charge in there to keep it charged and to keep it from going down. And in most cases, it's supposed to not be harmful for the battery when it's under that 3% range. I don't know the long-term effects of that. With lithium iron phosphate, you'll see that even the float voltage will drop from the charge voltage down to the float to get it off of that peak all the time. And I would suspect that even a trickle charge would cause it to stay closer to that peak most of the time. So that might not be really good for it super long term, but it's great for boat batteries when you're going to be out in your boat once or twice, every now and then, and to keeping them charged. Gary from Idaho asked, is there a simple way to test if my charge controller is working? Um, there's several ways. Most charge controllers you can connect through Bluetooth. You can connect the Bluetooth to your battery to see if it's got charging going on. You can connect a device like this in the panels to see if it's pulling the voltage from it. You can also hook up meters and shunts that run here on this part, which would measure the voltage that's going in. So there's a lot of varieties of ways to do it, but the easiest is to use the Bluetooth within here, or to measure to insert one of these in the line over here to measure the voltage coming in from the panels themselves. Can I mix brands of batteries in the same bank? Battery manufacturers will tell you no. To be honest with you, I do it all the time, and I've never had a problem with it. It is important that you keep, for the most part, you keep the chemistries the same, that you have the LPO batteries and the LifePod batteries all the same, or lead acid all the same, or whatever type of batteries. You keep them the same, because that means that these measurements are all the same, and that you don't have batteries competing for voltages in bad ways and stuff. So I personally don't have a problem with mixing them, but a lot of the manufacturers will tell you that you shouldn't use their battery, you shouldn't mix brands and stuff like that. But they'll also tell you that you shouldn't mix sizes of batteries, from 300 amp hour batteries and 100 amp hour batteries. And I do that all the time also, and I don't have any problems with it. Brett K from Tennessee asked, why does my inverter shut off when big load starts. 99% of the time, this is basically when the big load starts, your battery voltage, your battery is low, and you don't have enough power to supply it. Occasionally, it can also be that there is an influx of power, surge power for a device. And let's say that you have an inverter that can provide 1,000 watts of power, and you have a refrigerator come on that needs, 2,000 watts or 3,000 watts just to get it kick started and running. So that can be it also. So there's a couple of reasons. Most of the time, it is your battery is low. It seems to be the trending cause of it is that you don't have enough power to supply them that way. What is the main, I keep seeing that over here. I cannot see any chat. I'm going to refresh this window and see if I get chat back. Nope. It shows me that there is chat, but I do not see it. So I apologize if you guys are chatting and I do not see it, but I cannot see it. So apologize for that. Luke asked, what is the main reason people blow fuses in smaller solar systems? It depends on which solar system you're talking about, but you can blow a most of them would be this. In my case, it's going to be the independent battery. The fuses get blown. You size your wire and everything to handle the wire size here, and then you hook up an inverter that's bigger than it's supposed to be, and it pulls too much from the thing, or you have a short and it causes those to pop. Those are going to be the ones that pop first if you have a massive short, as opposed to these big ones over here. So it just all depends what it is, but most what is the main reason people blow fuses is you're trying to pull too much power. Usually it's not a short, but then the short is the main reason for it to be there. Next is, do I have to ground my panels if the frame is aluminum? And the answer is yes, you absolutely need to ground your panels, and the panels need to run back to the same grounding site as everything else. You need to share a common ground between your entire system. Jessica from Utah asks, can a bad crimp cause low charging performance? A bad crimp can cause low charging performance. It can cause excess heat. It can cause a fire. It can cause bad performance. It can cause low voltage. It can cause low amperage. It can cause your charge controller to think the battery's full before it's full. It can cause things to shut off early. It can cause things to shut off late. It can cause your inverter to shut down. Battery connections and bad lugs are the #1 problem with systems. The #1 cause of issues is bad connections and bad batteries, bad battery connections. Alex R. from Texas asked, do I need a fuse between my charge controller and the battery? And I believe I got this question before, but the answer is absolutely yes. You do need a charge controller between the charge controller and your battery, preferably on your battery and on your charge converter. Maximum output of the charge converter or backfeeding to a charge converter can be very bad in a shorting situation. So you want to prevent that, but you also want to prevent the batteries from being over, so you want to fuse them independently also. Oh, that's why because the question's looped and we are already past the last question. So that basically is the show for tonight, and I know I had a couple of brief technical moments there. I apologize for that, but in review, we basically had the 4 major components of the sun brings in energy to the panels generate energy that goes into the charge controller. The charge controller converts this power into the right voltage for your battery system. Your battery system can then provide power to the AC side of the system, which is the inverter, and the inverter converts it from DC power to AC power to allow you to plug items in, allowing you to take power all the way from the sun into your toaster in the morning to make your toast or your coffee. And so I'm hoping that this gives you a good understanding of the four main components, which are panels, charge controllers, batteries, and inverters that you will need to provide to build a solar system. And if you are interested in building a solar system and want some additional help, keep in mind that I have a DIY solar class that is starting at the beginning of the year. It'll be its kickoff, and right now I have a 50% off to that class. And I am going to, in the live stream, on a little short about it that kind of shows you what the class will include, what you can get from it, and how it works. And hopefully that will help some of you out. If you are there is a link down below for a free one-on-one session with me. If you sign up, you'll get a free one-on-one session, so I encourage all of you to go sign up for that. And you can use that time to talk anything you want about your solar system, ask me any questions, go over it on one-on-one, take a review of your plans, and I'll provide you my feedback or whatever you need in that one-on-one session, that consultation. We'll be glad to discuss it. But it's completely free, no risk to you. I just like giving away a couple of these every month. So if you're interested in that, please sign up for it. It's in the link below. And thank you for watching this month or this week. I have not decided if I want to continue doing my live streams on Sundays or Mondays. This week was a really bad example. I kind of had a bunch of technical difficulties at the very beginning and didn't even have the live stream scheduled for public. I had it scheduled for private, so I did miss quite a bit there, and I apologize for that. Next week will be better. We will see all of you then. Thank you for watching, and enjoy the video. Over the last couple of months, I have shown you a lot of different solar builds. We have done everything from a $180 solar shed to the solar shed version 2 that had the solar 12-volt solar system built into it, to an RV 48-volt system, a DIY battery, or even my wife's coffee trailer setup. The one thing I keep hearing over and over from you is that I want to do this myself, but I don't know where to start. So I built something for you. I'm calling it simply the DIY Solar Class. It's a self-paced, approximately 12-week step-by-step course that shows you how you can design, wire, and power your own solar system the right way, the safe way, and without wasting a whole bunch of money the first time around buying things that you don't need. Learn from my experience. Each week, the curriculum focuses on one of the components in a solar system, either that be panels, batteries, inverters, wiring, real builds, real life situations, real designs, with all the details, with diagrams and videos so that you can follow along. I built this class because I remember when I first started how confusing my first solar system was. I didn't understand amps, I didn't understand volts, I didn't understand wire sizes. I understood electricity a bit, but fuse ratings confused me. Different types of fuses confused me. There was so much information overload that putting it all together with a random selection of videos out on the internet was very difficult. So this class is intended to put it all together. It takes everything that I've learned from dozens and dozens of builds and all the mistakes that I've made along the way, and there have been a bunch of them, and turns it into one complete roadmap that you can follow step by step and get the information you need. So if you've watched my videos or wanted to build your own system, this is how we can do it together. Let me give you an idea of what is included in this class. So you're going to get a step-by-step video lessons for each part of the solar system. Printable diagrams and parts list. Either you can follow them exactly, or we can work together to modify them to meet just your specific needs. We'll do a live Q&A session every other week just for the class so that everyone gets all of their questions answered. I've also included a one-on-one call to go over and to review your designs, or just talk about what your solar system is involved, and make sure that you're comfortable and have all the questions you need in that one-on-one setting. Not only that, but you're going to get lifetime access to all this content as I update it as we go along, so that you can go at your own pace, come back at any time to refresh, and when I add new content, you already got it. You can always come back and pick up where you left off, or rewatch the entire course anytime you want. If you've been waiting to build your own solar system, if you're looking for the perfect gift for someone who wants to build a solar system, if you want to put solar in your shed or on your RV or take your house off grid, this class is for you. This is why I made it, to give you that one-on-one help to make sure that you do it right and you do it safely. Founding members right now, between now and the December 31st, get 50% off the class. Starting January 1st, the class goes to full price. So right now, if you sign up, you get it for half price. That's a lifetime membership. You'll never be taken out of the class. You can join today at mattmansolar.com/class or click the links below. Either way, I'm going to keep teaching on YouTube. I enjoy it way too much. But if you want to go deeper, if you want to know exactly what you need for your system, this class is for you. If this sounds like what you've been looking for, head over to mattmansolar/class or just scan the QR code on the screen to grab your spot. Founding members get 50% off through December 31st, and we kick things off on New Year's Day. I'd really love to see some familiar names from the comments inside and help you design, build, and update your system step by step. The link's below, and it's also pinned in the top comment. See you inside. Over the last couple of months, I have shown you a lot of different solar builds. We have done everything from a $180 solar shed to the solar shed version 2 that had the solar 12-volt solar system built into it, to an RV 48-volt system, a DIY battery, or even my wife's coffee trailer setup. The one thing I keep hearing over and over from you is that I want to do this myself, but I don't know where to start. So I built something for you. I'm calling it simply the DIY Solar Class. It's a self-paced, approximately 12-week step-by-step course that shows you how you can design, wire, and power your own solar system the right way, the safe way, and without wasting a whole bunch of money the first time around buying things that you don't need. Learn from my experience. Each week, the curriculum focuses on one of the components in a solar system, either that be panels, batteries, inverters, wiring, real builds, real life situations, real designs, with all the details, with diagrams and videos so that you can follow along. I built this class because I remember when I first started how confusing my first solar system was. I didn't understand amps, I didn't understand volts, I didn't understand wire sizes. I understood electricity a bit, but fuse ratings confused me. Different types of fuses confused me. There was so much information overload that putting it all together with a random selection of videos out on the internet was very difficult. So this class is intended to put it all together. It takes everything that I've learned from dozens and dozens of builds and all the mistakes that I've made along the way, and there have been a bunch of them, and turns it into one complete roadmap that you can follow step by step and get the information you need. So if you've watched my videos or wanted to build your own system, this is how we can do it together. Let me give you an idea of what is included in this class. So you're going to get a step-by-step video lessons for each part of the solar system. Printable diagrams and parts list. Either you can follow them exactly, or we can work together to modify them to meet just your specific needs. We'll do a live Q&A session every other week just for the class so that everyone gets all of their questions answered. I've also included a one-on-one call to go over and to review your designs or just talk about what your solar system is involved and make sure that you're comfortable and have all the questions you need in that one-on-one setting. Not only that, but you're going to get lifetime access to all this content as I update it as we go along so that you can go at your own pace, come back at any time to refresh, and when I add new content, you already got it. You can always come back and pick up where you left off or rewatch the entire course anytime you want. If you've been waiting to build your own solar system, if you're looking for the perfect gift for someone who wants to build a solar system, if you want to put solar in your shed or on your RV or take your house off grid, this class is for you. This is why I made it, to give you that one-on-one help to make sure that you do it right and you do it safely. Founding members right now, between now and the December 31st, get 50% off the class. Starting January 1st, the class goes to full price. So right now, if you sign up, you get it for half price. That's a lifetime membership. You'll never be taken out of the class. You can join today at mattmansolar.com/class or click the links below. Either way, I'm going to keep teaching on YouTube. I enjoy it way too much. But if you want to go deeper, if you want to know exactly what you need for your system, this class is for you. If this sounds like what you've been looking for, head over to mattmansolar/class or just scan the QR code on the screen to grab your spot. Founding members get 50% off through December 31st, and we kick things off on New Year's Day. I'd really love to see some familiar names from the comments inside and help you design, build, and update your system step by step. The link's below, and it's also pinned in the top comment. See you inside. All right, thanks everybody. I really do appreciate you coming. Thank you to all my subscribers. Thank you to all of my members who get access to the videos before they come out. I know you've had a lot of content lately to deal with. We are still a few shy from 16,000 subscribers this week. We're at 15,979. I've got 21 to go, but I do want to celebrate that a little bit. Make sure that I say thank you to everybody and that you guys are wonderful, and I really appreciate it. I appreciate everything that you do. And so we will certainly see you guys again next time, and hopefully I'll have that 21 subscribers then. And if you are interested in the class, you saw the video about it. The link is down below. If you're interested in a one-on-one session, I'm giving them away. In addition to, you can schedule them on the website. That's linked down below for that. And if you have any questions, please feel free to leave it in the comments. And thank you again to everyone. I really do appreciate everything that you do and the wonderful the wonderful support that all of you have provided. 15,979 way exceeds my every expectation for the first few months of our channel here. It has just been wonderful working with all of you, and I really do thank all of you. Again, we will celebrate 16,000 next week, but for this week, thank you so much for participating in the live stream. Thank you so much for watching, and we will see you next week. Talk to you then. Over the last couple of months, I have shown you a lot of different solar builds. We have done everything from a $180 solar shed to the solar shed version 2 that had the solar 12-volt solar system built into it, to an RV 48-volt system, a DIY battery, or even my wife's coffee trailer setup. The one thing I keep hearing over and over from you is that I want to do this myself, but I don't know where to start. So I built something for you. I'm calling it simply the DIY Solar Class. It's a self-paced, approximately 12-week step-by-step course that shows you how you can design, wire, and power your own solar system the right way, the safe way, and without wasting a whole bunch of money the first time around buying things that you don't need. Learn from my experience. Each week, the curriculum focuses on one of the components in a solar system, either that be panels, batteries, inverters, wiring, real builds, real life situations, real designs, with all the details, with diagrams and videos so that you can follow along. I built this class because I remember when I first started how confusing my first solar system was. I didn't understand amps, I didn't understand volts, I didn't understand wire sizes. I understood electricity a bit, but fuse ratings confused me. Different types of fuses confused me. There was so much information overload that putting it all together with a random selection of videos out on the internet was very difficult. So this class is intended to put it all together. It takes everything that I've learned from dozens and dozens of builds and all the mistakes that I've made along the way, and there have been a bunch of them, and turns it into one complete roadmap that you can follow step by step and get the information you need. So if you've watched my videos or wanted to build your own system, this is how we can do it together. Let me give you an idea of what is included in this class. So you're going to get a step-by-step video lessons for each part of the solar system. Printable diagrams and parts list. Either you can follow them exactly, or we can work together to modify them to meet just your specific needs. We'll do a live Q&A session every other week just for the class so that everyone gets all of their questions answered. I've also included a one-on-one call to go over and to review your designs or just talk about what your solar system is involved and make sure that you're comfortable and have all the questions you need in that one-on-one setting. Not only that, but you're going to get lifetime access to all this content as I update it as we go along so that you can go at your own pace, come back at any time to refresh, and when I add new content, you already got it. You can always come back and pick up where you left off or rewatch the entire course anytime you want. If you've been waiting to build your own solar system, if you're looking for the perfect gift for someone who wants to build a solar system, if you want to put solar in your shed or on your RV or take your house off grid, this class is for you. This is why I made it, to give you that one-on-one help to make sure that you do it right and you do it safely. Founding members right now, between now and the December 31st, get 50% off the class. Starting January 1st, the class goes to full price. So right now, if you sign up, you get it for half price. That's a lifetime membership. You'll never be taken out of the class. You can join today at mattmansolar.com/class or click the links below. Either way, I'm going to keep teaching on YouTube. I enjoy it way too much. But if you want to go deeper, if you want to know exactly what you need for your system, this class is for you. If this sounds like what you've been looking for, head over to mattmansolar/class or just scan the QR code on the screen to grab your spot. Founding members get 50% off through December 31st, and we kick things off on New Year's Day. I'd really love to see some familiar names from the comments inside and help you design, build, and update your system step by step. The link's below, and it's also pinned in the top comment. See you inside.